try example 5.32 here. It says a truck is carrying a toolbox, but the rear gate of the truck is missing, so the box will slide out if set in motion. The coefficient of kinetic friction and static friction between the bed of the truck and the box is 0.355 and 0.65 respectively. Starting from rest, what is the shortest time the truck could accelerate uniformly to 30 meters per second without causing the box to slide? Okay, important part there, no sliding. That's telling me static friction, meaning there's going to be a range. But they wanted to know the shortest time. Well, the shortest time means I'm going to have to pick the highest friction point. So mu sub s times normal force. The max force will give us the max acceleration and the shortest time. So let's go ahead and set this up. So I drew my free body diagram. I got gravity, I got normal force, and I have the force of friction. Now in this case, the force of friction is pointing forward because my toolbox, if there was no friction and I drove my truck, the toolbox would just stay there and fall to the ground. That's not what we want it to do. We want it to accelerate forward, therefore the force of friction must be pulling it forward so it accelerates with the truck. So since there is no sliding, the acceleration of the toolbox and the acceleration of the truck will be the same. I know my force of friction is going to be this mu sub s times normal force because I wanted that maximum force to get my maximum acceleration and my minimum time. So I need to go ahead and generate my force equation in the x direction where it is accelerating and my force equation in the y direction where it is not accelerating. In the x direction, I simply have the force of friction equals ma. Make my substitution for that maximum value, so mu sub s times normal force equals ma. When I get to this point, I will need to solve for normal. So the normal force I can find in my y direction. So I have normal force pointing up minus mg pointing down means the normal force equals mg. Make that substitution. So now I have mu sub s times mg equals ma, and I see the masses cancel. Now I know my acceleration. So now I can do a 1D motion problem. So let's do that over here. So I have x naught x, v naught v, a, and t. So the truck is going to start at 0 meters per second. It's going to speed up to 30 meters per second. I know I should do the list of variables because it said uniform acceleration. That means I'm going to be using those first four equations. The acceleration is our 0.65 times 9.8, our mu sub s times our normal force. And then our time is what we're looking for. So picking an equation without position, that would be equation number 1 for us. So I have v equals v naught plus at. Crossing out that is 0 and solve. So I have 30 divided by my 0.65 times 9.8, making sure to properly group these when I type them in my calculator. And I end up with a time of 4.71 seconds as the shortest possible time. Now, one thing to note on a problem like this is if there is a little bump in the road, any jostle in the back of this truck, that normal force can go to 0 in an instant, and the friction can go to 0 in an instant, and that box can start moving and we no longer have static friction. We have kinetic friction and that friction drops substantially, and so the acceleration would drop substantially, and that toolbox could easily slide out the back of the truck. Do not drive a truck with a toolbox without a tailgate. That's my advice to you.